Hello, my name is Kerem Ahmet Bayram. I am a student in the Department of Electrical and Electronics Engineering at Bilkent University. In this video, I will present my PHYS-102 lab project. In this experiment, I investigated how the capacitance of a parallel plate capacitor changes when the electric materials are gradually inserted between the plates. To do this, I used two circular conductive plates, and two different dielectric materials, such as wood and glass. The materials were inserted step by step, and the capacitance was measured at different insertion depths by using a digital multimeter. The physical background of this experiment is based on the capacitance formula for a parallel plate capacitor. C equals epsilon A over D, where A is the plate area, D is the separation between the plates, and epsilon is the permittivity of the material between them. When a dielectric material is inserted between the plates, the permittivity increases, so the capacitance also increases. First of all, I prepared the wooden dielectric material for the measurements. Firstly, I used a ruler to divide the wood into 4 cm intervals. These markings were important because they allowed me to control the insertion depth more accurately during the experiment. By using equal intervals, I was able to insert the material step by step and record the capacitance at specific positions. In this part of the experiment, I inserted the wooden dielectric into the capacitor step by step. The foot was moved gradually between the two circular plates, and at each marked position I measured the capacitance with the digital multimeter. This allowed me to observe how the capacitance changed as a larger portion of space between the plates was filled with the dielectric material. I also used the capacitance of the empty capacitor and the capacitance when the wood was fully inserted to estimate the electric constant of wood. Here I am preparing the glass dielectric for the experiment. I marked 4 cm intervals with a ruler so that I could control the insertion depth more accurately during the measurements. These markings made it possible to record capacitance values step by step. After that, I am inserting the glass dielectric gradually into the capacitor. I moved it step by step between the two plates, and at each marked depth I measured the capacitance with the digital multimeter. This allowed me to observe how the capacitance changed as more of the glass entered the capacitor. I also used the initial and fully inserted capacitance values to estimate the dielectric constant of the glass. These tables present the measured and theoretical capacitance values for both wood and glass at different insertion depths. In both cases, the capacitance increased as the dielectric materials was inserted further between the plates. The tables also include the estimated dielectric constants, the plate area, the plate separation, and the inserted area values used in the calculations. Overall, the measured results were reasonably close to the theoretical values and showed the expected increasing trend. Here, these graphs show how the capacitance changed during the experiment for both wood and glass. The first set of graphs present capacitance versus insertion depth, while the second set shows capacitance versus the ratio of inserted area to the total area. In both materials, the measured capacitance increased as more dielectric material was inserted between the plates. The measured values were also generally close to the theoretical values, which means that the experimental results followed the expected trend. The error values were generally low for both materials. The average percentage error was about 1.94% for wood and 2.57% for glass. This shows that the measured results were reasonably close to the theoretical values, although small differences were still present because of alignment errors, fringing effects, and measurement limitations. In conclusion, the capacitance increased as more dielectric material was inserted between the plates. Both wood and glass showed the expected trend, and the measured values were in reasonable agreement with theory. This shows that the objective of the experiment was successfully achieved.